Okay, so today in this video we're looking at operations with radical expressions. Before you watch this video, make sure you view my first video on simplifying radical expressions. Okay, so we're going to start with multiplying radicals. The rule with multiplying radicals is you can multiply different roots together as long as they have the same index. So in this case, we're multiplying two square roots together. The square root of 2 times the square root of 8, all you do is you multiply the radicands. So 2 times 8 is 16, and then we can simplify the square root of 16 to 4. Pretty easy stuff. An alternate way to do it is you can simplify your radicals first, then multiply. We know that the square root of 2 can't be simplified. We know that the square root of 8 is the same thing as 2 root 2. Well, if we multiply the radicals, root 2 times root 2 is 2, times the existing 2 that's in front as a coefficient, and that also gives you 4. So it verifies both ways work. I think the way we did it in red at the beginning was a little bit easier. The same thing can be applied to variables. Notice in this problem we're dealing with two cube roots, so because the index is the same, we are allowed to multiply these two terms together. So we're going to have a cube root. 3 times 9 is 27. Remember, when you multiply variables, you add their exponents. So x squared times x to the fourth is x to the sixth. And y to the first times y to the third is y to the fourth. Okay? And then from here, we're just going to simplify what we have left. The cube root of 27 is 3. And remember from our first video, you take your index and see how many times you can divide it evenly into your exponents. So 3 goes into 6 evenly twice with no remainder. So we can pull out an x squared. 3 goes into 4 evenly once, so we can pull out a y to the first with a remainder of 1. So the 1y goes back inside the cube root. Remember, once again from our first video, leave a little bit of space so this index doesn't get mistaken for an exponent. Okay, we can also divide radicals. And dividing radicals is pretty important because if you remember from geometry, you're not allowed to have a square root or any kind of radical in the denominator of a fraction. So a lot of people's first thought is, well, let's rationalize. Well, that's going to be a ton of work in this problem, and we'll explain that later on in this unit. But since we have like radicals, we can divide these two terms. So 32 divided by negative 4 is negative 8. Subtract your exponents, so x to the 10th divided by x is x to the 9th. And since they were both in a cube root, we now have one cube root that can be simplified. So we know that the cube root of negative 8 is negative 2, and the cube root of x to the 9th is just x to the 3rd. We got our answer very easily without having to do any rationalizing the denominator or any really complicated math. Okay, we can also add and subtract radicals. And the rule for this is, as long as you have like radicals, you can add your terms together. Think of it like an x or any variable. So we have 5 times root 2 plus root 2. Well, remember, there's an assumed 1 in here. So if we're thinking as the root 2 like a variable, 5 plus 1 is 6. We just have an answer of 6 root 2. And we're done. Okay? Don't add the radicands or multiply the radicands. You're just simply stating in this problem how many square roots of 2 you actually have. Now in a problem like this, I'm adding 3 terms together. Notice none of them have like radicands. This one has an 18, this one has an 8, this one has a 72. So we cannot add these together in their current state. These also all have coefficients. What we're going to do in this case is we're going to simplify each radical and try to get a similar radical. Okay, so I'm going to do this on the side here in a different color, then we can add all this together. Well, we know the square root of 18 can be simplified into square root of 9, square root of 2. So root 18 is the same thing as 3 root 2. We already know that root 8 is the same thing as 2 root 2. In the square root of 72, everybody always wants to start off with square root of 9, square root of 8. But remember, pick the largest perfect square. 36 goes evenly into 72 twice. So if we do root 36 root 2, that simplifies to 6 root 2. Notice all of our radicals now have a root 2 in them. All right, but the root 18 was being multiplied by root 6. So what you're going to want to do is take the existing coefficient of 3, multiply it by the 6 that was already out here. So 6 root 18 is the same thing as 18 root 2. You could even verify it in your calculator just to double check, but these are the exact same number. Okay, we're taking the 4 from the outside, multiplying it by the 2 root 2. 4 times 2 is 8. So 4 root 8 is actually the same thing as 8 root 2. Okay, in this case, we're going to do 6 times 3. So 3 root 72 is the same thing as 8 root 2. Now all we're going to do is put our coefficients together. Well, you can kind of notice already that the positive 18 root 2 and the negative 18 root 2 are going to cancel each other out. So we're just going to be left with 8 root 2. All right, that's it for operations. We're going to see some more examples in class.